Hey friends, I want to introduce a new sponsor to you, HMA VPN. It's a VPN you can count on. As you know, I do a lot of travel and I tend to connect to a lot of untrusted wireless networks, and I probably shouldn't, but I can use HMA as the world's largest VPN service. It offers the most server locations worldwide, covers 190 countries. There's always a server nearby. Doesn't log your IP address, and it allows me to connect 5 devices simultaneously. It works on basically all platforms, Android, iOS, Mac, Linux, Windows, routers, wherever. It's actually been completely redesigned recently to make it even simpler and more fun to use. And there's even a smart kill switch that'll turn the VPN automatically on when you launch sensitive apps. Here's your call to action, my friends. Try HMA VPN risk-free with a 30-day money-back guarantee. This deal is for Hansel Minutes listeners. That's hmavpn.com/offer-Hansel Minutes. That's hmavpn.com/offer-Hansel Minutes. Hi, this is Scott Hansel, and this is another episode of Hansel Minutes. And today I'm talking with Ben Eater. If you go to eater.net, that's EATER.net, you can see all of the great content and projects that he's working on. The one that he is known for and as people are excited about this year is building a 6502 computer, building on some of the work that he had done building a computer from basic parts. How are you, sir?
Good. How are you, Scott?
I am a little bit overwhelmed. I've got the psychic weight of this computer that's half built on my kitchen counter. I've been told by my spouse to move it into the dining room.
Yes, you've gone fully down the rabbit hole, haven't you?
I surely have. I almost I feel like I need a room to build this in because at first it was a desk and then a counter, and now it's the entire dining room table.
Yeah, sorry to have taken over your life there.
How did you decide that this was a thing you wanted to do? And I'm trying to understand I'd like to actually back up a little bit. Your background. Are you an electrical engineer? Is that what you took in college?
No. So I guess I started in college studying computer science and never ended up finishing that degree. This was sort of the mid 90s. And it turned out for a variety of reasons, to make more sense to just dive into industry. Mm-hmm. And from there, got heavily involved in computer networking. And so spent maybe 15 years doing sort of systems engineering with computer networks. And then from that kind of moved back towards software engineering and spent the last 7 or 8 years doing software engineering at Khan Academy. Mm-hmm. And so it was really at Khan Academy that I got interested in making my own content and started making YouTube videos on hardware, which had always been an interest and a passion. And, I've always been tinkering with various hardware projects and computer related projects. And so I started making videos of this 8-bit CPU from scratch as just kind of, a thing that I was interested in sharing.
Mm-hmm. There's a lot of diversity of knowledge and background in the computer science industry. We all call ourselves software engineers, and
Sure.
There's lots of people saying, "Oh, I'm a front end engineer, and I do jQuery, and I do Angular, and I do that." But we're all software engineers. But at the same time, though, someone may have gone to MIT and come out of that with a master's degree in these things and built an 8-bit CPU from scratch. Now you're telling me, and I'm just learning this for the first time, that you never even finished your degree and you're doing this. I'm feeling like, as I'm learning and going through this process myself, that I've clearly either missed a class or forgotten to take something. How did you pick this stuff up? Is this just literally reading and absorbing and reading and absorbing? Because not every front-end JavaScript engineer knows what an AND gate is.
Sure. Yeah, I think it's just been something I've always been around to some degree. So, as far back as high school and even middle school, I was interested in programming and interested in computer hardware and that sort of thing. And, back then, we didn't have Arduinos, but you could plug things into the printer port on your computer, and that gave you 8 bits of digital I/O that you could do things with, kind of like what people do with Arduinos today. And so, I would do that. And then the next level beyond that is, you can build a card that plugs into the bus in your computer, the old ISA bus. Mm-hmm. And that gives you more I/O possibilities. And so I'd done things like that. just tinkering around in high school.
Mm-hmm.
And then, like I said, a lot of that kind of went on the shelf for a while as I got into my career, focused more on higher level networking stuff, and then software, front end software engineering. And then that was something I just wanted to kind of get back into as a hobby.
When you put something like this together, though, you speak with a patient and a quiet authority, where I, as the viewer, am going, well, Ben really knows what he's talking about. And certainly there's always people on the internet saying, oh, well, you did that wrong, or I rewired the circuit that way, or whatever. But how do you feel qualified to build something like this? And did it take any amount of like, okay, I can do this. Like, I could build an 8-bit CPU from scratch, and I can say this and put it on the internet, and people will enjoy it.
Yeah, that's a good question. I mean, that's I think a good question for anyone. Like, when are you an authority on something?
Like, are you learning, or are you like the teacher that we've all had who's just one chapter ahead?
I hope I'm more than one chapter ahead.
I know that I'm several chapters behind. I'm enjoying that very much.
Yeah. No, I mean, these are, like I said, these are projects and things that I've always had an interest in, and so it's been something that I've been absorbing over, I think a long period of time, and so I've had a lot of time to sort of think about it and think about, how do I make sense of this? And I think to some degree that is what people find interesting or fresh about the content I'm making. Is I'm coming at it from, this is how my brain has processed this stuff over a number of years. This isn't a regurgitation of how it was structured in a textbook when I first learned it.
It is a culmination,
informed by experience. Yeah, and I think the traditional way that a professor might teach a class along these lines would be, there was some curriculum that was set out, and then that professor, learned that curriculum and has always had that framework for understanding it, and then that the gaps have been filled in over many years of experience, of course. But I think there's still that same fundamental framework underneath that. Whereas I think to the extent that I'm doing something new here, it's, because I didn't start with a framework and I just kind of pieced this stuff together on my own over a period of, at this point, a couple decades. I maybe have just a little bit different perspective on it, which is what I think people find interesting.
Right, and that perspective offers that freshness, and it's had a number of times where I've been doing stuff. Of course, I'm not doing the 8-bit CPU from scratch. I'm doing the 6502, which still feels pretty low level to me. And I've been doing this for almost 30 years, and I have had at least a half dozen times, including once where literal jaw drop. And I was like, I don't talk to myself. Some people sit quietly in their room and they have full-on conversations with themselves. But I literally was doing this. I think I was somewhere in like hour 11 or 12. And I literally was like, oh, and like, 30 years of like, I thought it worked this way and it worked that way kind of happened.
I'm really curious what that moment was, if you recall.
When I actually wrote a little bit about it, but it was one of those things where it was a combination of understanding the rising edge versus the trailing edge, like when things occur, the polling versus interrupts, and how data was flowing from the EEPROM into the computer and then out into the latched chip. And I had swapped 2 wires, so I had 8. Sure. I had my 8 bits. Wires 4 and 5 were swapped, and I was frustrated because this thing would keep getting like, let me look at. I wrote this up. I kept getting B2 and I wanted AA, and I was just getting angry, and I wasn't thinking. Right. I was just getting angry, and I kept thinking, I know what I want. I kept getting, and I was like, I've done something wrong, and I took the whole thing apart and rewired. Took the whole thing and rewired it, and I was thinking about things in terms of hex, and I think about hex in terms of colors because I've been spending so much time on the web. So AA, I can tell you what color it is, but I can't see the binary. So I stopped and thought, and I said, hang on, what the heck am I actually doing here? And that moment took me from simply following your videos and moving my hands the way you were moving your hands so that I might copy you, to a moment where I went, oh, B2 is 10110. Like, it's like I was trying to go 10101010.
Right.
And I said, oh, and my brain drew a direct line between there's 5 volts on that. I have literally flipped these 2 wires. And I just flipped them,
Yep.
and then the thing worked. And it was like it went from totally, completely, utterly useless, does not work, to worked exactly as Ben said it would because of these two wires.
Right.
And it was just a moment where software and hardware and electrons came together into this Venn diagram, and I just went, oh. And then I'm finding myself on my quad processor, Intel, whatever, going, how is this thing even working at all? Like, it's a miracle that the house of cards that
Right?
Ben has me building here is a thing.
It is, it is amazing. but no, yeah, I think that is an interesting insight. That as software engineers, the way you think about problems, you don't generally have to think about, maybe 2 bits on my bus are swapped.
And maybe the operating system, maybe they are swapped and the operating system is cleaning it up for me. When I was starting out, I think we're probably somewhat contemporaries in age. We were thinking about big endian and little endian on the network, and who was doing that, and who was paying the computational price for the endian swap as you move off the network and onto the processor. And now that's just long forgotten.
Yeah, but there's still
somebody's got to do it. Which actually lets me one thing I wanted to ask you, and I've mentioned this before in other shows, is that what do you think the value is about learning about the metal? Because a young person on my team said that they don't learn from the metal up as I did, and as it sounds like you did. They learn from the screen back. So for them, the metal is F12 tools, and then they tunnel into the computer from there until they decide that they've reached a layer of abstraction that they're comfortable with. I'm enjoying learning from lower down than I've ever been, and then tunneling back up.
I don't know that there's necessarily I don't know. I go back and forth on whether there's some, strong pedagogical stance I could take about why one is better than the other. And I don't know if I can, but the one thing I can say is that there is always a sense of mystery that you have when you look at a computer, unless you start from those first principles. Although I guess you still have to draw a line of like, where are those first principles? Because even if you start at the at the beginning with electrons, you could still keep going and asking questions about physics, and we don't know the answers to those. But I think if you're willing to accept some basics about physics and work up from there, then I think you can develop this sense that, okay, computers are not magical; they're just really complex, and it's miraculous that a modern computer does what it does, but it's miraculous just in the sense of like, wow, it's really amazing what humans can do.
And the idea that we've miniaturized it, and even now looking at your giant 8-bit CPU from scratch, I'm not 100% clear on inside the 7400 series chips and AND gate. Like, how is it doing the AND?
Yeah, I do have videos on that.
So I have. Okay.
Yeah, I've got videos where I talk about the chemistry of semiconductors and how a transistor works, and then how you can build AND gates from transistors. And then from that kind of launch into, okay, let's build a computer from gates.
Okay, so that is my missing piece then. Yeah, and I'm looking here on your YouTube, at YouTube/EaterBC, you've got all the way down to the lowest levels. And you have, and they're really, really well paced. But I still find myself pausing for a second because I need to absorb. You know what I mean? You don't, yeah.
Yeah, I mean, my goal is to not leave anything out. So I don't want this sort of hand wavy, like, okay, this is roughly how it works, and then like fast forward a little bit and here it works, and leave out some detail. I always want you to be able to say, well, wait a minute, why is that? And to have that answer in there somewhere. But at the same time, I don't want the videos to drag on and on and on and on, covering every little, detail in detail. So it's a balancing act. And I think, what you're recognizing is hopefully what I'm aiming for, which is that you can sit back and watch the whole thing, and I think kind of soak it in and get a sense of like, okay, this all makes sense. But then if you really want to understand it, you do need to go slower and really process everything that's there, because hopefully there is some information density.
If you go back, if one goes to your videos on YouTube and goes back to 6 years ago, there is a Khan Academy-esque style. It appears that you're using the same software and the same kind of style. And then somewhere as you get into the latches and flip-flops and the other stuff, you've developed your own style, which is, a black background in your hands and your peaceful voice and a pen. And most recently, you've even been taking pieces of paper with cutouts of other pieces of paper and doing this kind of cool replacement. Were you initially copying Khan because it was what you were doing at work? And then how did you develop your own style?
Yeah, it just happened naturally. I mean, I think just like you said, I was working at Khan Academy, and so I look at Sal and I see what he's doing. I was like, oh, that's working. Let me get a pen tablet and do that. And I started doing that, and then I think as I transitioned to the physical world, and that sort of forced me to change style a little bit, because with the pen tablet, of course, you've got the pen tablet. It's all digital, even though you're writing. But when I started pulling out, okay, here's a breadboard, here's a transistor, I started building something. It's like, okay, now I need a camera pointed at what I'm doing. And there are maybe some really old videos where I kind of toggled back and forth between the pen tablet and the camera, and that got a little bit cumbersome. And so, I just started drawing on paper, and then just, over time, the style developed to what it is. So, it very much was like, okay, let me imitate this thing that I see that works. But then as time progresses, it became my own.
Hey friends, you know how I love great podcasts, and I want you to check out the Code Newbie podcast. It's all about stories from folks on their coding journey. They talk to new developers, experienced developers, and everyone in between about how they got started learning to code, how they navigate their technical careers, and they also do deep dives into technical topics in a newbie-friendly way. Check out their podcast at www.codenewbie, that's NEWBIE.org/podcast. That's codenewbie.org/podcast. I love also that a community has built around your videos to augment and to fill in things that you might find easy or intuitive that they might find less so. So, for example, your videos, the ones that I'm doing through are the 4 main videos on the 6502, and they're between a half an hour and an hour long. And the last one I just did was 50 minutes long. And it took me about 5 to 6 hours to get through it, because there's moments where you'll say, I'm going to wire this, and then you fast forward time, and I pause it. Right, and there's a great community on Reddit under your Reddit on your name, where people actually made PDFs of chip diagrams that I can then paste to the top of my chips that have the pinouts. And I discovered that 5 hours into it, and it really sped me up and helped me out a lot.
Yeah, the community is really amazing. And I didn't expect that when I started making these videos, for sure.
They're very kind and very helpful, and they kind of acted as your tech support,
Yes, which I definitely appreciate, since I obviously don't have the time to answer every possible question from everyone.
Have you made this your full-time thing? Is this what you're doing now?
It is, yeah.
What is that like? Do you like just wake up and wait for the spirit to move you, or do you like gotta make the videos?
It's somewhere in between. Some days I feel a little more inspired than others, but the downside, I guess, of having that community is I do feel like I owe something to these people. And, I've made a commitment to getting this series of videos out. And at the same time, I'm thinking about, okay, what's the next project I'm going to do? And, but yeah, it's certainly different than, previously when I was at Khan Academy working on a software engineering team.
A lot of people, since I've been building the 6502, and I get to be clear to the audience, what I did is I discovered Ben's site. I watched the videos. I was like, oh my goodness, I want to build that. I thought about buying the parts, and then I went and saw that you had done all that work for us and bagged them and put them in a box. So you can buy a kit to do the projects that Ben does yourself. I bought the kit, and then I also got the clock module, and that included an EEPROM programmer. And then I bought an inexpensive, tiny little oscilloscope. Each time I felt I was in over my head, and people are asking me, well, what level should I be? How do you answer a question like that? How do you say where should people be to be able to do this project?
I don't really know how to answer that question. I mean, the best answer I can give is watch all the videos. Just sit down and binge the series and draw your own conclusion. I mean, the videos don't hide anything, I don't think. That's not my intent anyway. So, the question is, can you do what you see me doing, and do the things that I'm saying in those videos make sense to you? Can you follow along? Do you feel like, oh, I'm getting left behind and I'm not really sure what's going on here? But I think if you watch through a series that they're thinking of, if you're interested in the 6502 series, watch through those 4 videos and just kind of judge for yourself. Like, did that make sense? Did the parts that were a little hand wavy to me, do I think I could dig in and really understand that? Or were there just concepts that just, I just feel like I have no idea where to even get a toehold? That would be my advice is just watch the videos. They're free. And yeah, come to your own conclusion about whether it makes sense to you. And I think if it does make sense to you, I think you've got a pretty good shot at being able to do it yourself. Now, you will find as you do it yourself that there are lots of things you probably didn't pick up on in the videos when you watched them the first time. So it's not necessarily going to be an easy project, but that's to some degree the point. I mean, I think it's a unique aspect of this is that it's not a kind of a paint by number kit where you just pull the things out like a Lego set and just snap it together and it works.
That is a really good thing to point out, because I didn't think it was, but also I didn't really realize that I didn't know a bunch of things. Like you do some cool stuff to move the process forward. You've got pre-stripped wires. They also have to be pre-bent. So I'll pause something and you'll go, yeah, here's 16 pins here, 16 pins, and then you've gone and you've hooked up the Arduino and you're going to do 32 pins of just, and then that's like a half an hour. And I had to, and then you also undo it and do it again and undo it and do it again. And I was just like, takes some time. And then I go and I learn other techniques. I get a wire stripper, or I go, well, this isn't the right tool for the job. I'll use this tool. There is the assumption that there's a certain amount of familiarity with these portable breadboards, with the ability to use a multimeter, even where I thought I knew how to use a multimeter, but I really didn't until I was forced to.
Yeah, it's interesting because I think I'm learning as well, like where the gaps are with people, because there's certain assumptions I make that they're obviously baked into the videos because I made them, and then I'm realizing, oh, wait a minute, okay, maybe some of these things are not obvious to people, or the things that I thought might be challenging. But that's where it's really encouraging to me to see the community stepping up and filling in some of those gaps for people.
And I keep asking myself, though, because I have taken EE classes, albeit 30 years ago. You'll say something casually like, oh, and this is happening on the rising edge, or, well, this is a pull-up resistor or a pull-down resistor. And then it's like, oh, my goodness. And then I'm off watching someone else's video on what a pull-up resistor is. And I go to myself, should Ben have done that? Like, like how far, are you going to become the Khan Academy for all things electron?
Yeah, I don't know. Like, yeah, does it make sense for me to make a video on pull-up resistors? I don't know if it does. Other people.
The question is, though, when I hear a word I don't know or a phrase, and I like, oh, this is a concept that people who do this should know, and then I go off and I learn about that thing.
Yeah,
that it is definitely a self-starter project. I like that you said it's not paint by numbers.
Yeah. No, I think for sure. But I think if you are sufficiently motivated, it's hopefully.
Yeah, well, I've been having a blast. Like I said, I'm about 11, 12 hours into it. I've made it through 2 videos, taken over that one part of the house. One of the things that's interesting also about these videos from a very much a self-learning perspective is, do I stop when I got it to work, or do I stop when I understand how I got it to work?
Right. Yeah, I would encourage you to stop.
No, I get it. Like I got the clock to work and I moved on to Hello World. And then I said, I got to back up and remind myself how the clock works, and get a few sleeps in to put that memory into medium storage so I don't lose that short-term memory.
Right.
And then right now, I'm on part 2, moving into part 3, and I've got it working, but I'm having some, I don't know, I'll just call them quantum effects, or, some Heisenberg uncertainty principle, where if I look at it, it changes it. And I don't know, well, but there's a reason, though. And this is the part, because you've baked me in with multiple hours of like, well, this is deterministic. If something's not working, there's a reason. It's kind of cool. There's no one to blame, but God himself and yourself. I can't blame you. It works in your video. It must be me or the quarks that are preventing this from happening.
Right.
And that's the mystery.
Yeah. Yeah, I don't know what to tell you.
What do you do about that? Like, I've noticed, do
That's
you
gotta be
follow you? I
tough.
don't see that you're super active on Reddit, but people are super active on your Reddit, having conversations about, like, I don't know how Ben ever got this to work, and then other people are like, oh, but this is amazing. It worked on the first try. Are these? Is it just a matter of wires swapping, or is it quality of components? Some of the things about maybe the power supply doesn't have enough voltage. Have you seen some of those comments? And I'm curious your experience with how many people have had those issues when putting the kits together.
Yeah, I do generally try to follow the Reddit. I know I'm not super active. A lot of that though comes down to the fact that there are other people that jump in with the right answer sooner than I get around to it. But no, I am generally aware of some of those. I think one of the biggest things, as far as I can tell, is quality of breadboards.
Really?
This is something that this is something that I learned as a part of this project that I would not have suspected beforehand, which is that there is a huge difference in the build quality of different breadboards, and that's reflected generally in the price. I mean, I guess it's an imperfect proxy, but the difference between a $2 breadboard and a $10 breadboard is just night and day. And if you pull them apart, and at some point I want to do a video or at least a blog post or something, because I got some really cool pictures under a microscope of the parts and stuff when you pull apart a breadboard, and just the different, even just the different alloys of metal that they use in there.
Really?
Some are more springy than others.
Wow.
Yeah. So the really good quality ones, they use some alloy that's very springy. And so when you stick a wire in and out a bunch of times, it always snaps back and has the same, grippiness on that wire. Whereas the cheap ones will deform. And once you've, shoved a wire in and out, enough times, it just doesn't have the same grip anymore. And then you end up with these really sort of flaky connections.
And flakies are the problem.
And
like,
so
that's the thing.
And that's, oh yeah. Yeah. But well, as you mentioned, like you get 2 bits swapped and you have a computer that is not a computer. So one wire can really ruin the day.
It's so funny though, because it really, like, the lower level you get, it's so obvious, but again, I can't express enough what an eye-opening experience this is. Like, these may be silly and stupid questions that I'm asking, but it's like, yeah, that's the $1 million semicolon or whatever. It's like, yeah, like that one bit, that is now a brick. It was a computer a minute ago, and now it is no longer a computer.
Right. And there's
nothing. So, like, another thing that I've had is now that I've gotten farther into the project, I've got 4 breadboards all working together. I need to make sure that voltage is going smoothly across all 4, because I've lined all my rails up.
Yes.
Some people have suggested running power down multiple rails from multiple locations.
Yep. Yeah, that doesn't.
Is that a thing? Like, is that say, like, I can do that? I can get throw 5 volts all together and down each.
Yeah. In parallel, sure. Yeah. There's a video as part of the 8-bit CPU, which is 14 breadboards all sort of connected together, where I talk about power distribution, and that's one of the things I recommended in that video. And that's one of the things that is interesting about this, is that I'm doing it on breadboards, which I think most professional electrical engineers would look at that and say, "Why in the world would you do that? Like, just make a printed circuit board." They're cheap and easy, and you can get them turned around from China in a week or even less. Get a custom printed circuit board, solder everything on. All the connections are there. You design the printed circuit board in a EDA tool that does have a linter effectively, or a design rule checking, electrical rule checking algorithm thing that checks that. Why not do that? And I think the value of the breadboard is that it forces you to think about every connection in a way that, I think if you were to lay out the printed circuit board yourself and order your own, that might have some value. But this is something I'd always been frustrated as a kid. I'd buy these like educational electronic kits, and you get a bunch of components and you get a printed circuit board, and you'd solder the components onto the board and it would just work. And you wouldn't learn anything. So that's like I guess that's sort of the reason that I really like the build a computer on a breadboard idea of this forces you to get every connection right and think about every connection, and run into those problems where you have 2 bits swapped and you aren't getting the right result, and you pull your hair out for a couple hours trying to figure out why, and then realize, oh, I just had these 2 pins swapped or whatever it is. I think there's value in that. But it definitely comes with this downside of, well, now there's just a whole bunch of connections that could potentially be.
Yeah, there is a bit of psychic weight that what other things have I not found yet? and I'll get another few hours into the
Right.
next video and discover that, well, this, whatever the read write is swapped or something silly like that. But at the same time,
Sure.
I'm also
Yeah.
noticing that there's a certain temperament of a programmer where I have been frustrated, but I haven't been, slam my hand on the table frustrated. It's been more of a contemplative wander around the neighborhood talking to myself,
Well, you have to have that attitude if you're a programmer.
and I have very much enjoyed the, like, I don't think I can do this, right outside my comfort zone. I'm fully over my head on this project, but still I rise.
That's great.
Yeah.
Yeah. That's perfect.
I appreciate that. One of the other things that you did that I thought was really cool was the use of an Arduino versus a very expensive piece of machinery that I could potentially buy. Maybe you could speak about why we throw an Arduino in here and what that allows me to visualize.
Yeah. So if you're designing a digital logic circuit, one of the fundamental tools you would have in your toolbox is a logic analyzer, which is this thing that has, dozens of different probes that you can put on different signals, and then it will essentially sample the voltage levels on all of those signals and present it to you in some way that you can sort of see what's going on. So, in a computer like what we're building with the 6502 project, you've got a 16-bit address bus, you've got an 8-bit data bus, and as the computer's running, it's putting different addresses on the address bus, and it's reading or writing different data values on the data bus. And so if you were building this, or if you were engineering this thing, you might have a logic analyzer hooked up to all those different signals, and being able to monitor them over time. And then the logic analyzer will give you features about being able to, take those signals and view them in hexadecimal or whatever format you want. And I think you need something like that to really understand what's going on with a computer or to debug. I mean, the situation you had where you had a bit swapped, if you had continued down the path and built I/O and hooked a little LCD screen or something up to it, and you still had those pins swapped, I don't know how you would find that error without some type of logic analyzer. But for someone to be able to do this project, I think it's a tall order to say, buy a $300 logic analyzer, $1,000 logic analyzer or something. So because the computer's running so slow, you can actually use an Arduino that has the same number of data pins effectively as a logic analyzer, and just feed in all of those bits you want to monitor into digital inputs on the Arduino, and then have the Arduino just tell you what's on each of those pins. And the Arduino is not going to be able to read as quickly as a logic analyzer could, but that's fine because we can just slow down the computer.
Right, and I've got a potentiometer on the clock module, and I've turned it down to a nice, heartbeat tempo, and I've effectively got a real-time logging system. And what's nice about it is that, Arduinos are, ostensibly low level, but really quite high level. And you can write some very high level code to say, all right, I'm going to do this on the rising edge, and I'm going to check for high on that and low on that. And in about 13, 14 lines of code, I'm literally looking at that voltage. And when I was seeing that B9 versus that AA, and without that Arduino, there's no way I would have been, I don't even know. You're right. I have no idea how I would have figured that out. So let me ask this kind of ignorant question, because I've ordered a better oscilloscope. So I can go and look at one bit with a multimeter, and I can look at one bit over time as a voltage with an oscilloscope, and then a logic analyzer is kind of like both of those devices n times over time with all of their potential inputs.
Yeah, something like that.
Interesting. All right. See, I'm going to run down. I'm going to end up becoming an electrical engineer when I'm done with all of this stuff.
Oh my God. What we're doing to you.
It's been absolutely fascinating to do this. And I have only, in just a few minutes I've been able to talk to you, scratch the surface. The material that you've got up on your YouTube is absolutely extraordinary. And I love that you make it available for free. Folks can check out your stuff at eater.net, the video tutorials, whether it be building an 8-bit CPU from scratch, the 6502 project that I'm doing, as well as some really amazing videos we didn't even get a chance to talk about, like learning how the internet works, or your soon-to-be legendary, let's build a video card from scratch, which is really hot on Reddit. People cannot believe that you did that, and that's absolutely an extraordinary video series as well. I really appreciate you chatting with me today. We've been talking with Ben Eater. This is another episode of Hansel Minutes, and we'll see you again next week.